Assalamualaikum and hi everyone. So we are still in chapter 3, which is application of differentiation. Okay, on the previous lecture, so we have discussed 3 applications, which are rates of change, gradient of curve at a point, and local and absolute extremum. You still remember all the applications? Alright, so now we will discuss the fourth application, which is motion along a straight line. So this topic will be split into 2 parts. Okay, the first part is just the introduction, and then we will proceed by some examples in second part. Alright, so the learning outcome for this topic is at the end of this topic, students should be able to find the instantaneous velocity and the acceleration of a particle at any time t where its motion equation is known. So in motion, an object may rotate, vibrate, and trace a path in space. The form and the dimensions of the body determine the type of the motions. In this chapter, we shall assume the object to be a small particle and the path of the particle moves along a straight line. A moving particle changes its position constantly. The description of the movement will involve distance and direction. A movement along the positive x-axis is denoted as a positive sign. Meanwhile, movement along negative x-axis is denoted as negative sign. Thus, displacement, which is x meter, is a vector quantity where the distance is measured from a point or origin. And when a particle moves along x-axis, and if its displacement x can be determined at any instant time of t, then the displacement can be written as a function with respect to time. Okay, so we have this formula as the displacement. So this is displacement. Alright? And from this displacement, we can find the velocity, okay, which is we have v meter per second of a particle is the rate of change of the displacement, which is xt, with respect to time, t. And thus, the velocity is the first derivative of displacement with respect to t, which we can write as v equal to dx dt. Okay, where this v is the velocity. Okay, so first derivative of x with respect to t, so we will get v. Alright, next is the acceleration. Okay, we write as a meter per second squared of a particle is the rate of change of velocity with respect to time. Okay, thus the acceleration is the first derivative of velocity with respect to t, or the second derivative displacements with respect to t. Okay, which is we have a is equal to dv dt, and since we have v is equal to dx dt, so therefore dv dt also we can write as d squared, x over dt squared. So this is the acceleration. Okay, so to obtain the maximum or minimum displacement, so we need to have dx dt equal to 0 or v equal to 0. Okay, and furthermore, to obtain the maximum or minimum velocity, so we need to have dv dt or a, which is equal to 0. Okay, so this is